My name is Gautam Datta. In this video, I will mainly focus on convolutional function. So what is convolution function? Convolution function is a part of the feed-forward neural network, and the main objective of the convolution function is to extract the feature from any given input image. To extract the feature from any given input image, mainly the responsible element is the kernel or the filter. Now let us try to understand this with the help of an example, how the convolution operation takes place. Now suppose this is a given input image, and for the sake of simplicity I am considering this image is a grayscale image. It is a 5x5 grayscale image, and this grayscale image will be convolved with the help of this filter or the kernel. Now the idea is this filter or the kernel is mainly responsible for extracting the feature from this given input image. Now how this convolution operation takes place, let us try to understand this with this example. Now to extract the feature, what we have to do, we have to slide this filter of the kernel over this image. To begin with, suppose I am starting this filter or the kernel moving in this location, here in this location. That means now it will cover the grayscale image, this location, that is this particular location, it will cover 3x3. So now what we have to do, we have to take element wise multiplication and addition. For instance, suppose when we move this filter of the kernel over this region, then we have to take the multiplication, that is 1 will be multiplied with 3, plus 3 will be multiplied with this 4, plus 2 will be multiplied with this 4, plus 5 will be multiplied with this 1, and so on. So this will give the result 49. So this way we can get this value 49. Similarly, we can get 72. To get 72, we simply have to slide this kernel or the filter one step ahead. That means now the filter or the kernel will cover this location, that is 3, 2, 4, 6, 8, 3 and 4, 7, 8, and the same operation, that is element wise multiplication and addition, it will give result 72. This way you can calculate 81, and to calculate 85 the same thing, simply we have to just slide this filter or the kernel one row below. That means now it will cover 5, 6, 8, 3, 4, 7, 3, 2, 4, and the same operation, that is element wise multiplication and addition, this will give result 85. So this way we can calculate the convolved output. This is the convolved output. Now what we can see here, that the convolved output image size is reduced, it is 3x3, whereas the input image size, it was 5x5. How to calculate this convolved image size? The formula is n minus f plus 1. What is this n? This n is the size of the grayscale input image. This is 5, hence the value of n is 5, minus f. What is this f? It is the size of the kernel or the filter, that is 3, that is 5 minus 3 plus 1. Preserve the size. To retain the size of the convolved image or the convolved output, we have to use the another concept, and that concept is known as the concept of the padding. So in case of padding, the same thing, here the image is the same, this is a 5x5 image. Now this 5x5 image is padded with all the zero values in the border. So this is, we can say, one layer of padding. And here again the same thing, we are having the 3x3 kernel. So this is the input image, that is it is a 5x5 input image. This 5x5 input image is padded with one layer of padding with all the zeros in the border, and we have to take the convolutional operation, the same process, element wise multiplication addition, and we get the convolved output. Now here we can see that the convolved output size is a 5x5, which is same as that of the input image size. So this way, with the help of the padding, we can preserve the size of the convolved output. Now to calculate this convolved output, which is same as that of the input image, we have to use the formula, that is n plus 2p minus f plus 1, where this n is the size of the input image. Here it is 5x5 image, hence the size of hence the value of the n is 5, and the 2p, here the value of the p padding, here we have used one layer of padding, hence the value of p will be 1, that is n plus 2 minus f. The value of f is a 3x3 kernel, hence the value of f is 3. So that is n plus, that is 5 plus 2 minus 3, that is plus 1. So this will give the result 5. So this way we can calculate the size of the convolved output. and here we can see that the size of the convolved output is same as that of the input image, which is 5 by 5. So with the help of padding we can preserve the size of the convolved output. To summarize, the convolutional function is mainly used for pre-processing of the data, in the sense that for the purpose of extracting features, and to extract the feature the main responsible element is the kernel or the filter. Thanks for watching. Thank you.